Okay guys, let's give this one a shot here. So we're doing some definite integrals for the second half. For the first half, we're sticking with two other indefinite ones that are maybe a little trickier. Let's give it a shot. So, pretty normal u to pick here, the 1 plus x squared. I'm pulling this over. So we have this set up. Let's see how that's changing our integral over here. Notice I rewrote x to the 5th as x to the 4th times x, knowing that it's gonna help me out here. So as we're doing our substitution here, we can make this substitution, right? X dx goes here. Our issue becomes, what are we doing with that x to the 4th? We're just kind of stuck there, right? It doesn't look like there's anything else that could possibly happen. But I am gonna say that we can use this line and rewrite this. Does everyone agree that u minus 1 is the same as x squared if I just subtract that over? And we really have here two different x squareds. So we can kind of put this in here twice. U minus 1 times u minus 1. And at this point, we can actually multiply all these out and see what we're getting. Oh, and I forgot my 1/2 way along the way, didn't I? Whoops. My bad. Okay, multiplying all this through, we're getting u to the 5/2 minus 2 u to the 3/2. This one's minus u to the 1/2. Okay, this integral should be kind of straightforward. There's 1/2 is there. U to the 7/2, 2/7 comes out front. U to the 5/2, 2/5 comes out front, which turns into 4/5. Now we have to multiply through this 1/2, as well as putting in kind of the x values again. 1/7. 1 plus x squared goes in there. No, it's not u anymore. It's 1 plus x squared to the 5/2. Oh, that's 1/3 there because the 1/2. 1 plus x squared to the 3/2. So, a little bit longer process here. But the big takeaway is sometimes we get stuck and can kind of rearrange this u statement here to help us with what's going on with kind of our main thought. Let's try that same idea over here with integrating tangent. So you may be thinking, oh, we're in u sub, it should be easy, it's just tangent, but then that doesn't really do much for us. So we do want to relook at tangent as sine of x over cosine of x. And so we got to select our u carefully here. There's only two options. The option is cosine here, because our derivative is going to get us negative sine of x dx. So bringing that negative over, sine x dx is the same as negative du. So sine of x over u dx, that sub is made at the cost of a negative sign. And we can integrate this. It's going to be negative ln of u. We know u is the same thing as cosine. And then if you check books or online, a lot of them have it actually written differently, because this negative, remember when you bring it inside, it's like to the power of a negative, which is like 1 over cosine. which is really the same thing just as the ln of secant of x. I think the books has absolute values. Those don't really make much of a difference. I'm good without them. Just kind of the process going through it. Okay, these are two of the harder ones we could look at for regular indefinite integrals. Let's check out definite and see what these are like. So notice here, we do have bounds, and we're gonna see how that's gonna change our life here. So our u should be 2x plus 1, du equals 2 dx. And so if we are going to make any trade ever, dx is 1/2 du. Let's start seeing what's going on though. When I put things in here, square root of u dx. It's still from 0 to 4 because we're with respect to x. But as we change it here, the 1/2 comes over. It's u to the 1/2. We have du. Notice we're now with respect to u, whereas before we were with respect to x. So we have to change these bounds here. They can't just stay 0 and 4. So I have to think, when, we can even do it over here, when x is 0, that means that u equals 2 times 0 plus 1, which is really just 1, right? It's coming directly over from here. Now we're going to do it. We pick 0 there. That 0 became 1. Now we're going to do the same thing, but when x is 4, that implies, that's an arrow, that u equals 2 times 4 plus 1, which is 9. So now our bounds have changed from 1 to 9 that we're in u world. And we can go through this and just kind of solve normally. U goes to the 3/2. What comes in front here, we should have a third. And then no plus c needed because we actually have bounds. So we do have to write this from 1 to 9. 9 to the 3/2 may get some of us. That's like the square root of 9. And here, it's like we have the square root of 1, which is 1. Going through and doing all this. This is 27 thirds minus 1/3, which is 26 thirds. So notice with this process, we start in x world. Once we switch to u world, the bounds have to change to correspond with that. Let's try one more example, just so you see how these are going. Same thing. We're going from 1 to 2. Here of dx over 3 minus 5x, quantity squared. So our u here will be 3 minus 5x. And maybe we can think of it like this. Okay, let's start reworking this over here. I know this integral is like 1 over u squared, and we still have this dx that's here. Notice I still have the bounds there because we're still with respect to x. As soon as we make this shift now, -1/5, that's u to the -2. Now that we're with u world, we've got to go over here and decide what those bounds are. So we need to think, well, when x is 1 and when x is 2, what do we get? And the reason we're going 1 and 2, those are the bounds we have. So when x is 1, let's see. 3 minus 5 times 1, which is -2. So where the 1 is, we should have a -2. If we're plugging 2 in here, 3 minus 5 times 2, which is -7. And we should be able to integrate and solve this. You may be noticing the bounds are flipped. We could flip back correspondingly, or we can keep it the same. It doesn't really matter. I know this u is going to go to the -1. The negative comes out front. And I'm just keeping them the same. No plus c needed. Now let's start putting things in. 1/5 times -1/7 minus 1/5 times -1/2. Once we go through and do all of this and simplify, we're getting our answer here as positive 1/14. Okay, so the ones we're looking at tomorrow, our homework, we got 47 and 53 to 63 odd. Just odds there in 5.5. Great. We'll see everyone tomorrow in class.